Good day, everyone. I'm Siting Palhatiosay, our teacher for today, and our topic is solving linear inequalities in one variable. Our objectives are graph intervals on a number line, solve linear inequalities using the addition property, solve linear inequalities using the multiplication property, solve linear inequalities using transitive property. Solving inequalities is closely related by solving equations. Inequalities are algebraic expressions related by inequality symbols. Here are the inequality symbols: less than, greater than, less than or equal to, greater than or equal to, and not equal to. We solve an inequality by finding all real numbers solutions for it. What is linear inequality? Inequality says that two expressions are not equal. A linear inequality in one variable can be written in the form ax plus b is less than c, where a, b, and c are real numbers with a is not equal to 0. A solution to a linear inequality is a real number that will produce a true statement when substituted for the variable. Linear inequalities have either infinitely many solutions or no solutions. Let's have the properties of inequalities. We have three properties of inequalities: the addition property of inequality, multiplication property of inequality, and the transitive property. First is the addition property of inequality. Solving an inequality means to find all the numbers that make an equality true. Usually, an inequality has an infinite number of solutions. Solutions are found by producing a series of simply or equivalent equations, each having the same solution set. We use the addition and multiplication properties of inequalities to produce equivalent inequalities. If A is less than B, then A plus C is less than B plus C. If A is greater than B, then A plus C is greater than B plus C. In words, adding the same number to each side of an equation does not change the solution set. For example, 2 is less than 3. 2 is less than 3. Let's add 1 both sides. 2 plus 1 is less than 2. 3 plus 1. 2 plus 1 is equals to 3 is less than 2. 3 plus 1 is equal to 4. This is an example of the addition property inequality. That's it. Next is the multiplication property of inequality. The same positive numbers may be multiplied to both sides. The inequality is reversed if you multiply both sides by a negative number. Next is the multiplication property of inequality. The same positive number may be multiplied to both sides. The inequality is reversed if you multiply both sides by a negative numbers. For all real numbers a, b, and c is not equal to 0. A, the inequalities. A is less than b and ac is less than to b and c are equivalent if c is greater than 0. B, the inequalities is a is less than b and ac is greater than b and c are equivalent if c is less than to 0. In words, each side of inequality may be multiplied or divided by a positive number without changing the direction of the inequality symbol. Multiplying or dividing by a negative number requires that we reverse the inequality symbol. For example, x is less than or equal to 6. In multiplication property of inequality, let's try x is less than or equal to 6. In both sides, let's add 5. 5x is less than or equal to 6 times 5. Copy this one. 5x is less than or equal to 6 times 5 is equal to 30. and copy, and let's divide into 5 para makancel yung 5 at maging x na lang. Copy this one again. X is less than or equal to 30 divided by 5 is equal to 6. That's it. And this is the multiplication property of inequality. That's it. Next is the transitive property. If A is greater than B and B is greater than C, then A is greater than C. If A is less than B and B is less than C, then A is less than C. In math, inequalities are just as important as equalities. The transitive property also applies to inequalities is that if A is less than B and B is less than C and A is less than C. To visualize this property, consider 3 people whose heights are unknown. It is known that Anne is shorter than Bob and that Bob is shorter than Charlie. Logic allows the conclusion that Anne is also shorter than Charlie. This property works in the reverse order as well. If A is greater than B, then B is greater than C, then A is greater than C. Let's have an example. 7 is less than 8 and 8 is less than 10. Have the transitive property. 7 less than 8 and 8 is less than 10. If 7 is less than 8 and 8 is less than 10, then 7 is less than 10. And this is the transitive property. That's it. The graphing linear of inequality. Here are the graphing symbols. If we use greater than, then it is open circle. It indicates that this is not equal to the numeral graph. And if we use greater than or equal to, it is a closed circle. It indicates that this is equal to the number graph. And if we use less than, we use open circle and it indicates that this is not equal to the numeral graph. And if we use less than or equal to, we use closed circle and it indicates that this is equal to the numeral graph. Let's have an example. 7x plus 9 is greater than or equal to 10x minus 12. Let's have the example 7x plus 9 is greater than or equal to 10x minus 12. We're going to transpose the negative 12 to the 9. 9 plus 12 and is greater than or equal to 10x, and we are going to copy the 7x and we are going to transpose the 7x here. 7x. 9 plus 12 is equal to 21. 21 is greater than or equal to 10 minus 7 is equal to 3x. And to cancel the 3, let's divide it into itself. Divide 3. Divide 3. And let's cancel the 3. 21 divided by 3 is equal to 7 is greater than x. And if we are going to graph this one, 7, 6, 5, 8, 9. Greater than or equal to is not circle. Is a shaded circle. And going to the left. And this is 7 is greater than x. That's it. And that's another example. X minus 12 is greater than 8. Let's have another example. X minus 12 is greater than 8. Let's add 12 to both sides. X minus 12 plus 12 is greater than 8 plus 12. X negative 12 plus 12 is equal to 0. X is greater than 8 plus 12 is 20. X is greater than 20. Because X is greater than 20, let's graph this one. 20, 21, 22, 19, 18. Because this is greater than, this is open circle. And because X is greater than, the arrow is going to the right side. And this is one of the example in linear inequalities in one variable. That's it. Solving a linear inequalities, first is simplify each side separately. Clear parentheses, fractions, and decimal using distributive property as needed and combine like terms. Step 2, isolate the variable terms on one side. Use the additive property of inequality to get all terms with variables on one side of the inequality and all numbers on the other side. Step 3, isolate the variable. Use the multiplication property of inequality to change the inequality to the form of x is less than k or x is greater than k. That's all for today for our topic for the solving in linear inequalities in one variable. Thank you, class.